Welcome back. This is the last and the final method on the synthesis of alcohols. Of course, like I said, I will be uploading separate set of videos for phenols, but this is just primarily on alcohols. So this is method number 7. So here we have an ether. Now, you should not have trouble identifying this because we did a whole separate material on functional groups. So this is an ether. You're starting with an ether. You have an oxygen sandwiched between two bonds. That's called an ether. And when it reacts with a concentrated acid, all right? Now, I'm going to write another compound right next to it, okay, plus HBr concentrated as well. Now, I want you to pay attention to the product and how the product itself will be different, okay? So we have two ethers. One of them is symmetrical, right? This is a symmetrical ether, right? And this is an asymmetrical ether, right? What does that mean? On either side of the O, the groups look not the same, and on this one, the group looks the same, right? So you got a peak, here, there's one peak and there's no peak, right? And if that's the case, then when you break this, okay, your hydrogen would go with the O, okay? You break the side basically right here for this one. Whichever side is long, okay, you're going to rewrite that. That would contain the Br. Don't add extra carbons, just add the Br where the O was, and then add the O to the hydrogen and just leave it be. So the hydrogen would go with the oxygen, and then the Br would go to the carbon, right? Now, this is the case. These are the two products, okay? So the Br would go with the carbon that's the longest part of the chain, and then the hydrogen would go to the carbon that's part of the smallest chain. Now, in this case, it's symmetrical, so it really doesn't matter. So one is OH, and the other is Br. So basically, you chop it off on one side or the other when it's symmetrical, add OH, add the hydrogen to the oxygen, and the Br to this end. And so these are your two products, right? So while in this case you get alcohol and alkyl halide, here also you get alcohol and alkyl halide. But we're primarily interested in this is probably the least efficient method because we are producing also another product in addition to the alcohol that we've made. So this is probably the least efficient method that out of the 7 methods we've discussed, because in other case the byproducts were not really major products. In this case you get 2 major products, so the efficiency of producing this in large quantity is really less. So, but nevertheless, this is one of the methods, and the important thing is you pay attention to whether the ether is symmetrical or asymmetrical. That would determine where the Br would go and the hydrogen would go, right? Maybe at some point we can really pay attention to the mechanism if you are interested. Otherwise, this should be good enough. And that concludes all of the synthesis methods for alcohols. And then I'll post a separate set of videos for synthesis of phenols. And then we would complete objective B, which is applying these alcohols to produce other compounds. All right, so stay tuned.